Good morning all. So in this problem we have to construct a rectangular pyramid of dimension 35 and height 65, and it is resting on HP with a side base perpendicular to VP, and the pyramid is cut by a section plane which is perpendicular to VP and inclined at 30 degree to HP. The cutting plane meets the axis of the pyramid at a point 30 mm below the vertex. From the vertex we have to consider a 30 mm height, and we have to draw an angle line for 30 degree here. Okay, draw the development of the remaining part of the pyramid. So you can see in this problem the pyramid is resting with the base edge perpendicular to XY. So that's why it is placed like this. So we have to construct the pyramid first, pentagon of dimension 35, and then the slant edges, and then the front view. So first we are constructing an XY line here. Okay. So you can construct the XY line by using thickness 0.25 and 0.13. So there is no problem. Here in this problem I am using 0.25 mm thickness, and write XY HP VP because we are using an first quadrant here. Okay. So here pentagon of dimension 35 we have to construct. So for this we have to go to the polygon by center command. So go to polygon by center and select 5 sides. So rest with respect to the base edge perpendicular to VP, and then select any one edge and change the dimension to 35. So it will get changed. Then after that go to line and draw 5 perpendicular bisectors. Okay. First we have to draw the 5 perpendicular bisectors. How to draw? From corner point to the exactly opposite middle point. You have to draw the straight lines here. Here the inside lines should be thick lines. In the case of prism it is thin lines. Okay. So for these pyramids we have to draw the thick line because these are the slant edges. Then we have to retain only the lines which were coming from the end points. So that makes the slant edges. Okay. The top view of the pyramid. So we will be writing the namings. You can write it A, B, C, D, E, however it is given in the question. So we can write it in the same way, O01. Okay. So draw the front view of it. So by projecting the lines, okay, that is projection lines here. So you can draw the front view of it. So draw the straight lines. So you can zoom in and can do it. Okay. Sometimes you are not able to do it. You just have to zoom it properly, and then draw the projection lines. Okay. Okay. Here the height we have to consider 65 mm. Okay. 65 mm height. So draw 65, type 65, enter. Okay, here the front view of the pyramid, it is a triangular face, we get it here. Join it, and you can show the dimension here. You can make that axis line, show the dimension. Okay, now you can see here there is a section plane, and it is at a height of 30 mm from the vertex. That means from that O dash point I have to draw a vertical line 30 mm below of it, and then I have to consider a section plane there. Okay, so go to line and take axis line only. So from that end point I will be drawing vertically downward 30 mm, enter and click, and here I will give the angle. So here, so what is the angle you have to give? We have to give an angle of 30 degree to the HP plane here. You can see that 30 degree to HP, not to the axis. Okay, these things are very important. Inclination to axis or HP we have to consider clearly. Otherwise the problem will become wrong here. Okay. So go to extend to next and extend it. Okay, now we can show the angle. So here the angle shown, it is for the HP plane. Okay, angle shown here, it is for the HP plane. Okay, you can see that. So that is correct. can show the angle. Okay. You can see here we have to mention the, you can use that split command. Okay, use the split command so that we can able to exactly split it, because we have to dark that lower part and we have to make that upper part above that sectional plane a thin line. Okay, so that's why we have to use the split command here to make like that. So select the lines and make upper part as a thin line. Select those and make it 0.13. Okay. Now we can give the naming here for these cut points. Okay, you can give 1 here, and number 2 can cut it. You can see here. Now we can give the naming as it is there in the solution book. Okay, we try to do it as it is there in the solution book. Okay, so that will be better. Those things I'm going to delete it, and then again I'm going to rewrite it. So it will be easy and convenient, so that we can follow that solution book. So you will not get confused here. Okay, now we can give the naming for that section cut plane. 1, it is cutting there, and 2, it is cutting on the slant edge BO, and 3, it is cutting on the slant edge CO. Okay, and the point number 4, it is cutting on the slant edge DO. Here there is no vertical edge, here it is a slant edges, and 5, it is cutting on a 5 vertical edge EO. Okay, now you can see here we have to find out the true length. The true length, it is here. So CO is the parallel line, so you can consider that CO dash length as a straight line here. So from these 2 points, okay, distance between, using 2 points I am measuring this true length here, because it is pyramids, we know that it is done by using radial line method. Okay, radial line method. So now we can project these lines, that is from 1 and from 2 to 4, just project the straight lines so that we get the points on this slant edge. Okay, true length, on the true length we have to get these points. Okay, because we have to consider the true length here. That's what the radial line method. Okay, so here we have to mention 1, 5, this is 2 and 4. Okay, now we are getting all the points on this same straight line. Now we have to measure it. Okay, we have to measure this line so that it will be easy. Using distance between command, by using 2 points you have to do it. Select properly. Again you have to go to there. Okay, same way. Again you have to select, because it will be selected only one time. So that means you need to again you have to select it. Now all the lengths we are getting it. Now I'll be drawing a vertical line for a true length, that is 71.49, and then I will be cutting the arc. Okay, vertical line I'm drawing for 71.49. Okay, after this I'll go to arc by center command. So go to arc by center command, select this line length and draw an arc. Okay, draw an arc. We can select this whole thing and we can take it little lower so that the sweep can be increased. Okay, sweep can be increased here. So here Pentagon pyramid having base here 35 mm, that is we should cut 5 arcs here, because it is having 5 edges. Okay, it is having 5 base edges. So 5 arcs for a length of 35, we can cut it from that reference point. You can take that exact point by zooming in. Okay, zoom in and you can select the exact point. and give the radius 35 and cut the sweep. Okay, that's how you have to do it. The same way from there also you can mention, give the sweep 35 and enter. Okay, you can extend it. Now we can join it using straight line. You can see that we have to draw the slant edges here. Okay, slant edges. You can zoom in and connect it properly. Zoom in and connect. Zoom it properly so that you can get the exact points here. Okay. Can give that as O, and that is capital A, capital B, capital C, capital D, capital E, and capital F, capital E only. Okay, A, B, C, D, E, A. Okay, now we have to measure these lengths and we have to cut the arc with respect to point number 1, point number 2, like that. So point number 1 having a distance, again go to arc by center, and point number 1 having a distance of 41.98. So give the radius, enter, and cut the arc. The same way we have to do it on the another vertical edge. A here, the same length, that is 41.98. Cut the arc. Okay, give 1 and 1 here. Now the second arc we have to cut it for a length of 30.5 here. Go to arc by center. Okay, on the vertical edge here, give the radius 30.5, enter, and cut the arc. And on E also we have to cut the same length, 30.5, because 2 and 4 having the same length. Okay, 30.5. Now on the point D and the point D, we having a point number 4. Sorry, on a point D, we having a okay, here 1 I can change it to 5. Okay, no problem. You can see that point number 2 and 4 having same length, and point number 3 having 26.1. Okay, now we can join it using a straight line with a thick line here from point number 1. You can see here, you can join, zoom in and try to connect. Okay, zoom in and try to connect, zoom and try to connect these things. Okay, okay. In the lower part also we have to draw the base edges. You can see that from A to B, and so in the upper part I am going to make it thin, because the lower part only we have to make it thick. Okay, so for that I'll make that as a thin line here. Okay, now the base edges we have to construct, that is A, B, B, C, C, D, D, E. Okay, we have to join it with a straight line here from A to B, then B to C. Okay, here I have done mistake, so I have not joined properly to the vertical edge C here. I will select and delete it, and I am going to construct it again here. Okay, there is no problem. Join it properly, zoom in and connect. Yes, this is where we have to join. Okay, connect it. So you can subscribe for the channel and share it to the maximum students, so that they can be benefited from this YouTube channel, and hit on the like button and hit on the bell icon for the latest notifications. Okay, so with respect to the VTU syllabus, I have made these videos. I think the exams are near, so you can share it to the maximum students, so that they can be benefited. Most of the colleges, this development of lateral surfaces they are doing for the first time, so it will be easy for you so that you can make use of these videos. Thank you for watching the videos, and give the suggestions how we can improve upon the video quality, understanding and all. Thank you all. Thank you for the video. You can see we have to show the dimensions for it. Here the slanted length we have to show, and the base head length 35 you have to show it. Okay, but in the problem you can see, so in the problem, pentagonal pyramid given 30 mm and 50 mm height rests vertically with one of its edges parallel to VP. So we have constructed it is parallel to VP, and near to it you can see it is parallel. It is cut as shown in the following figure. You can see that it has been cutted here. You can see here edge OC, it's not parallel, so we have to rotate and make it parallel here, and then it projected it will get the true length here. We don't have any true length here, so none of the edges in the top view, that is OC, OB, OD, are not parallel here. So we have to make it parallel by rotating OC, okay, rotating OC, making it parallel, and then project it upward, rotating OC to make it parallel here. In this problem we have made it parallel, and then project it, we are getting the new true length here. Okay, new true length. On the true length we have been projected 1 2 3 4 5. Okay, first take a reference point and construct the true length here. Okay, so here the true length it is 56 mm. Okay, take compass and draw an curve or the arc. Okay, so measure 30 mm, measure any one of the 30 mm edge, and cut 5 arcs here because it is a pentagonal pyramid, so you can cut 5 arcs. So you can extend that curve. Okay, so total 5 arcs you have to cut because it is in pentagonal pyramid. Okay, now connect with this with the vertical edge. Okay, join these all these arc points, the straight line, because it is in pyramid. Okay, now erase that curve. Okay, so you can mention B, C, D, E and again here. So we need to measure the arc length, the new true length which have been drawn. Okay, new true length 1 0 1. So you can cut 2 arcs here, 0 1 on OA and 0 2. Okay, you can measure it exactly on the true length and the new true length which we have been drawn by rotating the OC line. Okay, that is 1, that is 2. Okay, and 3 we get it on exactly on C point here. Okay, exactly on the C point, extreme corner point. So you can mention that. So that is C, that is 3. Okay, on D we have point number 4, we can measure it using compass, cut the arc, that is 4. And then on 5, so we've been projected this 1 2 3 4 on the new true length which we have been drawn. From there we are measuring the length. Okay, So that's not the slant edge, we have drawn the new slant edge. That's what your true length. Then you can connect all these points with the straight and with the help of the scale. So join all these. So now we can dark. So this is what the retained upper portion. Okay, you can see that particular portion I'm darkening it. So we have to dark it. Okay, so that's what complete the problem.